Okay, we looked at this there last week. This is the same access list lab that we looked at last week. Okay, I'm actually going to remove this connection to the internet because I don't need it for what I'm doing here now today with this. Might make this a little bit extended out there. Okay, so any of the access lists that we've been looking at to now, they were basically saying stop one host getting access to one host. So you're going in and you're saying config space. So let's say, let me just show you an access list here, and I'll tell you what I'm talking about. So let's say, I just open up Notepad here. So we say deny HTTP access from host 192.168.1.3 to host 192.168.3.2. Okay. Let's just put that up there, right? So we're going to 3.2. So we put it on the 3.1 interface here, because remember, you should always put your access list as close to the destination interface as possible. And if you do that, then it's always going to be outbound. Okay, so 3.2 is here, 3.1 is there, outbound. That'll sort that out. Okay, so let me just click on this. Just check to make sure 1.3, for example, has HTTP access. 192.168.3.2. Yeah, okay, perfect. Right, so you go into Dublin, enable CISCO as a password, config space T, access list, extended ACL, so let's say 115 or 125, that's fine. What are we saying? Deny HTTP access. Okay, so you're saying deny, yeah, question mark. HTTP is part of the TCP protocol, yeah, and now it's host. So you're going to say host, a single host. So you'll say deny TCP host, and then you're going to say 192.168.1.3 space to host 192.168.3.2 space equal 80. Okay, so this is your access list. Access list 125 deny the TCP traffic coming from host 192.168.1.3 to host 192.168.3.2 over port 80. Okay, we've done that a few times. Hopefully you understand the concept there behind it. Now, creating the access list is the first part. It won't work until you apply it to a physical interface. Now, I'm not going to apply this to an interface because I want to look at a different access list. I want to, that was just to kind of refresh into the ones that we've kind of been doing so far. But what if I want to deny HTTP access from the 192.168.1.0/24 network? So basically, everyone in this network will be denied HTTP access to 3.2, the whole network. So the last times we were saying 1.3 is not going to have access to 3.2. But we want everyone here not to have access. Okay. In order to do that, you need to use what's known as wildcard bits. Okay, wildcard bits. Let me show you. Open up Paint here. I was up from the cursor there. There it is. Okay. Okay. So you need to specify what's known as 192.168.1.0/24. Okay. Now, if we look at the subnet 192.168.1.0, ticker 192.168.1.0/24. So it's going to be 255.255.255.0. That's the subnet. That's a network address, and that's a subnet we want to deny. Okay. So what we need to do is you don't use your subnet mask, you use wildcard bits. And wildcard bits are like the inverse of the subnet mask. And you use wildcard bits if you want to specify a range of addresses. If you say one host, you just say host 192.168.3.2, but that's only one IP address. If we were to deny 254 IP addresses, then you use wildcard bits. Okay, and how you find the wildcard bits for this subnet 255.255.255.0 is you use this formula 255.255.255.255. It's always that 255.255.255.255, and you subtract from the subnet mask 255.255.255.0. I'm subtracting in red. So you have 255 and you take away 255, you're left with 0. You have 255 and you subtract 255, you're left with 0. You have 255 and you subtract 255, you're left with 0. You have 255 and you subtract nothing, you're left with 255. So the wildcard bits for 255.255.255.0 is 0.0.0.255. Okay, any questions on that? And nope. The way, what you do is, how you remember, or somebody say, why would you use wildcard bits? In a way, wildcard bits is actually a little bit easier to understand than subnetting. I'll show you. So what's the very first address in this subnet? Well, like the very first, not the usable host, the very first IP address here. So the very first address is 192.168.1.0. And the very last address is 192.168.1.255. So there's your first address. And there's your last. Now, if we have the subnet 192.168.1.0, and we take this wildcard bits 0.0.0.255. I'm just going to get rid of this one down here. That's because it's just going to get in the way. And we subtract. No, sorry, excuse me, not we subtract, we add. So 192 and 0 is 192. 168 and 0 is 168. 1 and 0 is 1. 0 and 255 is 255. So this 192.168.1.0 with the wildcard bits of 0.0.0.255 covers everything from 192.168.1.0 to 192.168.1.255. Everything in the middle. And that's what we want to do. We want to deny access from 192.168.1.0 to 192.168.1.255. So that's the whole range from this whole network is going to be denied access to host 192.168.3.2. Okay. I'll do another one because I just wanted to get to I wanted to kind of just sink in a bit. Let's say we wanted to do 192.168.1.0/30. Now /30 gives us 4 IP addresses. So what we do here, so let's say, for example, we wanted to deny just the first, we want to deny 192.168.1.0, 1.1, 1.2, and 1.3, all these addresses. But let's say we had another host here, which was, let me just copy this. Can I copy this? Another server down here. And this is 192.168.1.7. So if I wanted to only block server 1.2, 1.3, and 1.1, I wanted to allow 1.7 in, right? What would you do? Well, 192.168.1.0/30 will cover everything from 192.168.1.0 up until 192.168.1.3. 4 addresses. That's /30. What's the subnet mask of a /30? It's 255.255.255.252. To get the wildcard bits, you take 255.255.255.255 and you subtract 255 is 0, 255 is 0, 255 is 0, 255 minus 252 is 3. So the wildcard bits for 192.168.1.0/30 is 0003. And that will cover everything from, remember, if you get a network and a wildcard bits, you just add them up and that will give you the range of addresses. So 192.168.1.0/0003 will be 192.0 is 192, 168.0 is 168, 1 and 0 is 1, 0 and 3 is 3. So that will cover everything from the first address 192.168.1.0 to the last address 192.168.1.3. So those 4 addresses will be blocked from getting access to host 192.168.3.2. Let me show you. Okay. Sorry, we'll do it on the Dublin River. So, top. Enable. CISCO. Fixed by C. So what we're doing, we're going to create an access list, and we're going to say 155. What are we doing? We're going to deny, okay, what TCP traffic, because TCP is HTTP, yeah, coming from source address is 192.168.1.0 space source wildcard bits. Where are we going to? 0003. And question mark, where our destination address? Our destination is just our host, a single address, because we're going to host 192.168.3.2. So you'll say host 192.168.3.2, and then equal 80. So you're saying access list 155 deny TCP traffic coming from 192.168.1.0 with the wildcard bits. So that's, you just add 192.168.1.0 onto 0003, and this range of addresses will be denied access to host 192.168.3.2 over port 80. Is that okay? Then we need to apply it. So we're going to apply it to 3.1 interface. So exit. So we do show IP int ref. 3.1 is FA0/0. So config space T interface FA0/0. IP access group. Same thing. What was the number? 155 was it?
Yeah.
I think it was, yeah, 155. I have IP access group 155 and the outbound. And let's check it out. So host 192.168.1.3, 192.168.3.2, blocked. Right. Oh, we're not finished. Duh. Okay, because remember, if we just deny, I was just so worried about, if we just deny one traffic, if I do a show access list, what's going to happen? Let me just delete 125. No access list 125. So, and I do show access list. So we've got one access list there, 155. We're just saying deny the TCP traffic, but if we do nothing there, it's going to deny all traffic. So we need to do access list 155 permit IP any. Very, very important. I just even forgot it there, like, so important. It's very easy to forget as well. Like. Okay, so we'll try that again. One 192.168.3.2. Yeah, it's not working. Okay, it's not working, and because it's not meant to work. Now, we should be able to ping 192.168.3.2. Ping 192.168.3.2. Yeah, but we just can't HTTP onto it. Yeah. But if we go in here, we've got a server here, and I go in and I say, oh, this IP address 192.168.1.7. Let's see this guy. 192.168.3.2. Yeah. Why? Because the access list doesn't cover 192.168.1.7. It only covered the first 4 IP addresses, which was 192.168.1.0, 0003. You just add the two of them together, you get 192. So that covers everything from 192.168.1.0 to 192.168.1.3. That's denied HTTP access. How's that?
Grant?
Yeah, is that okay?
Yeah.
Any questions on it?
And you can modify it for any list of IP addresses. You can modify it.
Well, yeah. Now, so you can. There's other things you can do with it. So you can have odd bits, and you can have odd IP addresses and even IP addresses. But we won't go into that there. But yeah, so you can say it's very useful for range of addresses. So so this gives you your start address 192.168.1.0 and your end address 192.168.1.3, and you just add them up. It's easier than the subnet mask, because you can know straight away, the list of affected addresses by just adding up the network part and the wildcard, and that will give you the first address, and that'll give you the last address, and everything else in the middle will be in the range. Okay. Any questions on that? All right. So I want to do a lab. That we'll do a lab together. We'll do this lab. It's the NAT lab. Okay. So if you go into day, where are we going? Day 10 into your Dropbox. We've got a NAT lab here. This is what we discussed yesterday, partly. Just 1 second. A bit chilly in here. I've got a heater here. Just wait. So yeah, if you can just open up that NAT lab, guys. Let me know when you've done it.
Yep.
In Dropbox. Good one, Tony. She's done it.
Right there.
So we've got Lee, Agart, Gary, Pablo, Richie. Is anyone still waiting to open it up, or are we all ready to go? If you're still waiting, let me know. I've no problem waiting. Okay. All right. So this is really what in conjunction what we did yesterday. Okay. So there's 2 steps to this lab, right? Let me just explain this lab first. We got we have a network here, 192.168.0.0. This is a private network, okay? We want to set up DHCP. We're going to set up R1 as a DHCP server, okay? So R1 is 0.1 to hand out IP addresses. So it's going to act as a DHCP server. So when PC3 contacts R1 and says, because R1 is also going to be DHCP, it's going to say, can I have an IP address? R1 says, yes, of course you can have an IP address. You can have 192.168.0.10 or something. But the problem is PC3 gets 192.168.0.10. As this happens, as it stands, PC3 is not going to be able to go out to the internet. Why? Because our DigiWeb, which is the ISP, has got access lists blocking the private IP address range to go to google.com. So we need to set up network address translation to take this IP address 192.168.0.10 and translate it to this IP address here, 193.95.170.0, sorry, 170.2. So as this is passing across, the router R1 will take this IP address 192.168.0.10 and translate it across to 193.95.170.2 and keep an eye on the port number. Let's say it's 1050 and send it on to Google. Google will respond back with a web page and will reply to 193.95.170.2, port 1050 comes into the router, and the router from the port 1050 is able to say, oh, that's PC3 and send it on here. Okay. It's just kind of going back over what we looked at yesterday evening. Okay. So the network subnet mask was 192.168.0.0. slash 20. Okay. And what we have as well is over here, I've got a test Google web server. So it's running a HTTP web page. And yeah, we've got DNS as well. And I got an A record. I'm going to talk about DNS in a couple of weeks. So I got an A record pointing google.com to 212.147.132.2. Okay. So we'll do this lab together. There is a NAT lab. It's called NAT lab print. You open it up. And we're going to configure. So what we're going to do is we're going to configure DHCP first. Okay. So we're configuring DHCP on R1. Okay. So go to R1, go into CLI, and let me go through the commands. By the way, routing is already set up. We're using EIGRP. Don't worry about the routing. Routing is already set up. Okay, so what we're doing here is going in to config space T. This line here, IP DHCP excluded address. Well, that means that we're not going to hand out the first 10 IP addresses. They're going to be excluded from DHCP. They're going to be excluded from our DHCP pool, which is down here, which is this pool here. This is a pool of our DHCP pool of addresses, but we're not going to include 192.168.0.0 to 192.168.0.10. That's what this line says. IP DHCP excluded address. You specify a low address 192.168.0.0. You specify your high address 192.168.0.10. So what's the very first IP address that the client will get?
.11.
Exactly, 192.168.0.11. And then we go in and we create our DHCP pool, IP DHCP pool, and we give it a name. We call it Dublin pool, or in this case, net pool or net dub pool. It doesn't matter. Dub pool. Okay, and it says DHCP config. So anything in here we're going to type is we're going to use to configure DHCP. Okay. So what do we need to give? We need to assign the network, our pool of addresses. We're going to assign the default gateway. It's not default gateway, it's default router. I don't know why the command isn't default hyphen gateway, but it's not. It's default hyphen router. And our DNS server is going to be this Google web server over here in packet tracer. It's this guy here, 212.147. So we're just specifying the IP address of our DNS server. Okay. Okay, so specify your network 192.168.0.0, 255.255.255.0. That's your pool of addresses. Default hyphen router 192.168.0.1. DNS server 212.147.132.2 and exit. Let me know when you're finished that, guys, configuring that, your DHCP. All right. Okay. So, well done, yeah. Okay. So now, after doing this, so we're going to wait, go back to our PC, make sure that we've got a DHCP IP address. There's no point in setting up NAT if we don't have DHCP working. 192.168.0.11, 255.255.255.0, default gateway 192.168.0.1, DNS server 212.147.132.2. Check all that, guys. Any problems, let me know.
Yeah, my DNS is not showing the server.
Okay, then refresh it. How do you refresh it? Go to static and then go back to DHCP.
Yeah, that's good.
Go. Everyone else all right?
Yep.
Yep.
Okay, cool. Now, if with this PC here, can we get a web page from google.com? Let's have a look. Go to a web browser and type in www.google.com. No, why not? Because this packet tracer browser, this packet tracer lab is simulating an ISP. And DigiWeb is saying you can't get out on 192.168.0.10. That's a private address range. Private address ranges are not routable out on the internet. So what we need to do is we need to set up port address translation to translate or to change. Translate is just a way, is another word for change. To change this IP address, 192.168.0.10 or 0.11, to the interface address of serial, this is serial connection, FA or serial 0/0. This is serial 0/0. Okay, so as this packet is going into the router here, R1 will take this private IP address, which is unroutable, and will change it to 193.95.170.2, which is this interface here, and send it across to Google. Okay, Google respond. Who did Google respond back to? They respond back to 193.95.170.2, which makes its way back to here. And then R1 will take this and say, this, I'm able to identify this address from the port number. Maybe it was 5050. And they say, that was PC3. So what it'll do is it will change the 193.95.170.2 back to the private IP address of 192.168.0.11. How does it know it's PC3? Because it keeps track of the port numbers. And we talked about that yesterday. Okay. So let me actually just go through this. So basically, there's a few commands here that you have to do. Make it a bit bigger. Yeah. First thing you need to do is you need to specify what address ranges you want translated. And look what we got here. We have an access list. You see, access lists, I've talked about this last week, are not just used for security. Access lists are used for specifying ranges of addresses. They're just a list. Like, my shopping list to Tesco is going to be different than my list of jobs I have to do around the house. A list is just, it's just an order of items. And this access list here is an order of IP addresses that we want translated. That's it. So again, the access lists are multi-purposes. They're not just used for security reasons. Here, they're not being used. We're not using this access list for security reasons. We're using this access list to say, I want this private address range of 192.168.0.0/24 translated. I want it changed to serial 0/0. Okay. So the first command is we need to specify the addresses that we want changed. And look what we got. We got our wildcard back again. So it's a standard ACL, access list 1, permit 192.168.0.0, 0.0.0.255, basically covers everything in the 192.168.0 network. Any questions on the first line there? Okay, so we'll do it. Access list 1 or 5 or whatever. It's a standard ACL. What we're doing, permit 192.168.0.0 space 0.0.0.255. So that basically says create a list, and in that list put the 256 IP addresses in 192.168.0.0. That's going to cover the whole range. How do I know that? Because the wildcard bits tell me that. All right. The second line, IPNAT inside source list 5 interface serial 0/0 overload. There's a lot in that. We just take these two here. So access list 5. So the first one, we're saying we want this list of addresses specified in access list number 5. That's all we're doing. This range of addresses are part of access list number 5. The second line is, I want to set up IPNAT and I want to translate the source IP addresses. What source IP addresses? The source IP address is specified in access list number 5, which is these guys here. So we want to change the source IP addresses in access list number 5 to what? To interface serial 0/0. We want to change it to this interface address of serial 0/0, and overload means we can overload all of this range to one IP address. It's just the language is kind of a little bit, it's just different. It's jargon. Okay. Okay, so that's that done. There's that. Well, there's the first two. So okay, guys, as well, just be careful. I said access list number 5. Whatever access list number you're doing, you have to keep the same number in the second line. Okay, so access list 1, IPNAT inside source list 1. Make sure the two of them match. If it doesn't match, it won't work for you. Let me know when you're finished with that. So all right. So the last thing we need to do is tell the router, see, the router's not going to know which is the inside and which is the outside. So which interface is the inside? This is the inside. This is inside our company. Yeah. Everything in red here is inside our company. It's inside. We know it's inside. Typically inside networks will be private, will be 192.168.0.0. This is inside. Outside is the internet. The only one that kids will know when they're going out, you say, where are you going? I'm going out. I'm going outside. I used to do it myself. So yeah, I'm going outside. They won't tell you where, but it's just outside. It's a very generic answer. I'm going out. Yeah. So here in red, this is outside. Could be anywhere outside. Inside our company is private. Outside is the internet. Okay. You need to tell the router that. The router's not going to know. So you need to go into the interface of our private interface, which is FA0/0, and say, hi, this is inside. Exit. And then you say interface serial 0/0. And then you say IP.NET outside. Very important. If you get them mixed up, it won't work. Okay. Okay. So interface FA0/0, IP.NET inside. Exit interface serial 0/0, IP.NET outside. And we're done. Now we just need to test.
Done.
Oh, great. Okay. We finished, guys?
Yeah.
Okay. All right. All right, check it out then. So now it's done. We can go to our PC here, PC3, and see if we can ping google.com. Ping www.google.com. So now you may need to click fast forward time. Ah, look at that. There we go. Getting a reply from google.com. What else will we do? You can also go into your PC, PC3, and go and just type in www.google.com. Look, there we go. We got a web page from google.com. This is simulating or not. This is basically these packets are being changed to this IP address here, going across to google.com, coming back and getting changed. Is everybody able to get a web page from google.com?
Yes.
Yes.
Good, 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 good. What you can also do is you can view your NAT translation packets. If you go into R1 and type in show IP NAT translations, and it tells you inside global or inside local is inside your company, local is your private address. This is what gets changed to, which is your inside global 193.95. So inside, still inside your company, but it's your public address. Inside is your company, local is your private, global is your public. And outside local and outside global is basically the destination. UDP port 53 is DNS. What you can you can do is go on to PC3 and run a continuous ping. Just say, try a ping again, ping space -t space www.google.com, and then go into or 1 and do show IP NAT translations. And you'll see a load of ICMP packets. These are your ping packets being translated. Let me know, is that working, guys?
Yeah.
Yep.
Great. All right. All right. I think that's it. Like, I mean, yeah. Anything else? Anything with IPv6? You want me to go back over a few minutes? Let me know.
Sorry, is there any good websites you can do practice questions for CCNA?
Yeah, look, we'll go through questions. See, I don't want to go through questions yet because there's still so much material to go through. So I'd prefer if you go back over all of our material, like from VLANs and spanning tree and OSPF and IPv6. But the last couple of weeks we'll have a look at all of our test questions, simulation questions.
Okay, thank you.
No problems. I think it's really just a case of just revise, you know, and then when we know we go through all the material, then you can go, you know, start looking at, you know, specific questions then. Okay. Is that all right, guys? Any other questions then?
All good, thanks.
Okay, well,
Yeah, all good. Lee.
all right, we do that lab then. So if you get a chance, go back over IPv6. There is a lab on IPv6 as well. Oh, I think there is, 1 second, isn't there NAT troubleshooting lab? Let me see, before I let you go. Homework for you is just PC one here. One moment. Day 10. Yeah, there's day 10 homework. See, we're nearly getting away with it there. So day 10 homework. So use a packet tracer with, configure a network address translation. I thought there was a NAT lab as well. No, there's not. But there is homework there. So yeah, the homework is go back over that lab, go back over the videos, and you can do that IPv6 OSPF version 3. All right. Other than that, then we'll see you next Tuesday at 7 o'clock. Okay, that's fine, Liam. Thanks.
Well, have a good one.
Guys,
you.
thank you.
Thanks.
Thanks, Lee.
See you guys.
Yeah,
Bye,
bye.
guys.
Bye.
Bye bye.